A construction site has 120 tons of waste it needs to dispose of. The construction workers are only able to remove 8 tons of waste per day. 1. Find an equation that expresses the amount of waste at the construction site in terms of the number of days the construction workers have been removing the waste. So in this case, X is the number of days the construction workers have been removing the waste, and Y is the total amount of waste that needs to be disposed. Okay, so we need to find the y-intercept, which is how much waste there is after 0 days. Okay, and then the slope, which is the rate of change here. How many tons of waste are being removed per day? So in this case, we are starting with 120 tons of waste, right? That is what we start with. But we're only able to remove 8 tons of waste per day. So after 1 day, and maybe this will help here. So day 0, we're at 120 tons of waste. After 1 day, we've taken 8 tons out. So we're at 112. After day 2, we've taken another 8 tons out. So that's 120 minus 2 times 8. Let me write it this way. 8 times 2. So we're taking that 8 tons out twice, which is just another 8 tons from what we had before, which is 104. Okay. Day 3, another 8 tons. Okay, so now I've taken 8 tons out 3 times. So that's 8 tons out from what we had the day before. So I'm at 96 tons. Okay, and so on. Okay, so -8, that's our rate of change. That's how much we're changing with each additional day, right? That's what we're taking another 8 tons out each additional day. So our rate of change here is -8 tons. Now notice it's important to add that negative, right? Because we have a plus in the middle here. Without that negative, then you're actually have more waste with every day, right? So X here is the number of days. And so now that we have this relationship, we could just plug in however the number of days X that it's been since we started to find out how many tons of waste we still have, okay? What is the y-intercept interpreted? Well, the y-intercept is when X is 0, Y is 120, right? That first number is the Y value of the y-intercept. And what that means is if the construction workers have spent 0 days removing the waste, there will be 120 tons of waste remaining at the construction site. What is the slope interpreted? Well, that other number over here, the one by the X, the one next to the X, that's the slope. That's how much we change per day, okay? So we need to interpret it. So now we have to interpret this slope. The line has a, so if it's -8, that means we have a downhill direction going left to right, right? Because that means, so what's going on is, maybe it's easier if I actually keep the data here. So here's X, our number of days, here's Y, our tons of waste, okay? So after 0 days, we have 120 tons of waste. After 1 day, we've gone down to 112 tons of waste, right? So 112, which is somewhere down here. After 2 days, we're all the way down to 104, which is, let's say 104 is right there. After 3 days, we're down to 96. Okay, and so you could see we have this downhill trajectory. Okay, and that's always the case when we have a negative slope. Negative slope means you go downhill, left to right. Okay, So that means that if the construction workers work more days, there will be less waste remaining at the construction site. That's true. The more days you work, the less waste there will be. I should say that there's actually another acceptable answer here, and you could answer either one and be correct. Another way to look at it is if the construction workers work less days, there will be more waste remaining at the construction site, right? So that's saying that so if we have more days, we have, let's try to draw a straight line here. Nope. We have less days. Okay, and if we have, I'm sorry, less waste. And if we have less days, let me pick a different color. Less days, we have more waste. Okay, so this is probably, I think, the more obvious answer, but in this case, this works too. Okay, if the construction workers work less days, there will be more waste. Finally, if the construction workers work 8 days, how much waste would remain at the construction site? Okay, so we have the equation. We found it up here. The equation is y equals 120 plus negative 8x. So y equals 120 minus 8x. And we want to know what's happening after the construction workers work 8 days. So remember, x is the number of days. So I'm just going to plug in 8 for x. And I'm going to calculate that. So we could use a notebook. If you're comfortable calculating that with pen and paper, you could do that too. Okay. So I have 120 minus 8, that's our slope, and then multiplied by the 8 days we're going to be working. And let's see what our y value is. How much waste do we have? Oh, you see what I did wrong? I've used our mathematical notation for multiplication in R, and for R you have to really specify that multiplication. I need a times symbol in there. Without that times symbol, it will not know that I'm in multiplication. So let's run that one more time. Okay, we get 56. So after 8 days, that means there would be 56 tons of waste remaining. Okay, let's submit it. And we have it.